So Atkins Réalis has over 100 years of expertise in the hydroelectric industry, power generation, and renewables. They're looking to be a world leader and innovate existing hydroelectric facilities or transportation facilities and really start moving them forward in that next direction. Of course, with any kind of implementation, the first thing that you're going to have to get past is the reluctance to innovate. The users of the data sets, they've been doing this for a while. They know the processes. They just want to be able to do them faster. They don't necessarily want to do them different. So what do? A streamlined single architecture workflow in one piece of software, providing fast and accurate deliverables for not only project collaborators, but also for clients. We're looking at the ability to take 3D data, overlay that with your point cloud, validate that the design that was generated is actually matching up with the realistic point cloud in the real world environment. We want to be able to do flow analysis. This is a hydroelectric facility. We need to know how much fluid is going through that facility at any given time. For the data extraction, we now want to start generating those models using either info points to do automatic extraction of primitives or other solutions that are out there on the market. Again, we're looking at a workflow. In this case, Atkins has taken the point cloud data, reverse engineered an existing pipe route that wasn't originally accounted for, has passed that on to their designers so they can now account for piping routes that were not initially captured or initially designed and use them to update their models, use them to overhaul the facility, and again, get that efficient workflow. Using hyper-realistic mesh files, we're able to go in and combine those with design data to ensure that the models that we have are representative of the real world in current time. Atkins can then very quickly identify those variances, identify those changes, and make corrections as needed. We're combining technologies, we're combining workflows in order to establish the most effective capabilities for the intended use cases. Thank you, everybody, for having me today. I really appreciate it, being able to send you on out of here to the last networking party of the night. Who's ready to party? There we go. All right, so my name's Nate Solier. I'm an application support specialist for Alicia Mink. We're a software vendor, so I'm here today to present this case study on behalf of one of our customers, Atkins Réalis. So I really hope you enjoy, and we're just going to roll with it from there. So Atkins Réalis has over 100 years of expertise in the hydroelectric industry or just overall power generation and renewables. So over the course of their lifespan as a company, they're looking to be a world leader in being able to bring data, personnel, and industries all together so that they can collaborate and innovate those various existing hydroelectric facilities or otherwise transportation facilities and really start moving them forward in that next direction. Now, in this particular case, I'm going to be presenting the experiences of Daniel Price. He is one of the engineers at Atkins Réalis with over 34 years of expertise in both 4D modeling and animations, simulations, 3D modeling, and also being able to bring virtual reality into that workflow. Now, of course, with all those experiences also comes the observation for evolution within the industry. So we're talking about a company that's been around long enough to still use 2D drafting and start moving through those processes to do 3D modeling, virtual reality, and bring that training aspect, the innovation aspect to that overall industry and bring it to their products so as to give the best deliverables that they possibly can. So some of the issues that you're going to see and we've heard throughout this week, I'm just going to go ahead and do a brief reiteration. Of course, with any kind of implementation, the first thing that you're going to have to get past is going to be the reluctance to innovate. So I'm going to borrow a quote that we heard yesterday. I think it was from Mr. Craig for RMS, who borrowed it from Mr. Ford. If somebody was going to come and ask me to deliver something, they're not going to ask me for innovation. They're going to ask me for faster horses. In this particular case, dealing with the same thing, except now we're working against internal workflows. We're working against the users of the data sets. They've been doing this for a while. They know the processes. They just want to be able to do them faster. They don't necessarily want to do them different. So that's going to be one of our first big hurdles. In addition to that, in early adaptations of point cloud tools, we're looking at segmented tools, we're looking at heavy data sets, the hardware isn't necessarily there to keep up with it. So in this particular case, we're having to struggle against the ability that in data set number one, we're going to have to do our registration in point cloud solution A, Once we've done our registration, that then needs to go to an entirely different solution to extract meaningful deliverables from that point cloud, maybe generate your 3D models or simulations. That could be a different piece of software. So being able to go to and from those pieces of solutions, that takes time, that increases chances for fidelity issues. It also increases chances that there could be human error in between those processes. So what do we do? Well, in this particular case, back in about 2017, Daniel met up with us at a co-event and started the process for building the use case to implement a streamlined single architecture workflow in one piece of software. So over the course of a few years, Daniel started building up a business case, started realizing how implementing a streamlined workflow could really improve that workflow, really improve the fidelity of his data, increase the efficiency of generating his models, as well as his simulations, and providing fast and accurate deliverables for not only his project collaborators, but also for his clients. So what does that look like? In this particular case, we're going to break it down. There's a couple of different examples of what using point clouds can do, including validating new designs. So we're going to come in, we've seen it time and time again, a few different presentations this week. We're looking at the ability to take 3D data, overlay that with your point cloud, being able to validate that the design that was generated is actually matching up with the realistic point cloud in the real world environment. This particular case, again, we're going to be overhauling hydroelectric facilities. We already have the facilities in place. We got to make sure that the new pieces of equipment are going to match up with the facilities that already exist. Up next, terrain generation. Maybe we're going to be starting a new project, building a new facility. We need to know what kind of terrain we're working with at that time prior to generating our models, because that's going to provide us some decision-making data in order to implement the correct models for the correct location. In addition to using the terrain for generating those designs, we also can use that for analysis to maybe consider overbreaks and being able to take into account what kind of excavation needs to happen in order to fit the terrain for the desired model. Maybe we want to update the current as-built situation against the models that we already have. In this particular case, we've generated a model that failed to account for a particular landing, particular set of stairs. By going into the facility, scanning that data set, we can now readily and efficiently account for data that may not have already existed in the model. In addition, we want to be able to do flow analysis. This is a hydroelectric facility. We need to know how much fluid is going through that facility at any given time, make sure it's going to the correct location, make sure it's under control, and be able to, again, account for any meaningful stress points or structural issues that that flow could generate going through the facility. So in this case, we're going to go ahead and start talking about the workflow a little bit that Atkins has implemented in order to take advantage of point clouds with their workflows. So with Atkins, they've got two primary forms of collecting point cloud data. The first one is going to be an internal team that uses a combination of drone and terrestrial scanning implementation. That way they can get the entire environment. They can go through, capture the high fidelity scans that terrestrial scanners traditionally provide, as well as being able to provide drone captures that can get wider areas of data, be able to get to harder to reach areas, and therefore we still grab the entire environment. We grab all of the data that we need in order to facilitate that cohesive model. Additionally, some of that data may need to be subcontracted out. We're talking about a global company. They may not have access to every single site worldwide. So what do? We go talk to the subcontractors that have access to those sites, that can scan the assets and provide that data back to us. So once the data has been acquired, what do we need to do with it from there to actually make it meaningful? So in this particular case, there's going to be a couple of different methods for registration. So we've gone out, we've collected all of our scan data, we have multiple potential formats, we've got multiple scans. We need to bring that into, again, a cohesive space to make it look like something, to make it usable. So in this particular case, that can break down to a couple of different options. Maybe you use a proprietary software provided by the scanning hardware company. So I've seen multiple companies here today. They all have their own solutions for registration. In most cases, using those solutions is a very strong way forward. They've developed those solutions to be able to work with their data sets and make it as accurate as possible, as efficient as possible. Now, in addition to that, maybe Atkins Réalis doesn't have access to that proprietary software. Instead, maybe they can use our solution, InfoPoints, to register the data sets into a cohesive project when they don't have the proprietary software to do it themselves straight from the scanner. Now, from there, once we've registered the data, we've got it all put together, what do we do next? So in Atkins' case, they've then brought the registered data into InfoPoints, regardless of the solution that they decided to move forward with for that registration process. In this particular example, what we ended up finding is that Atkins had gone, they had outsourced the initial capture and registration process for their data set, brought it into InfoPoints, and using InfoPoints analysis tools and registration tools, they ended up finding that there was a deviation in the registration of over 6 inches that needed to be corrected. Using our tools and using that for the check, they were able to then go in, make the correction so that the data is accurate and provides that high fidelity registration that they need in order to keep moving forward. Now, again, we're talking about multiple forms of scanners out there in the workforce and being able to use them appropriately for the appropriate situation. In this particular case, that means we could end up with 2 different kinds of data, structured versus unstructured. Just to go over real quickly for those who may not know, for unstructured format, the best way to think about it, look at a text file. It's just a list of XYZ, RGB, Y values. Just a very quick way of capturing that data, storing that data, and then implementing it into a software solution. However, in that particular case, the data itself doesn't have any extra information to it. It's kind of just, for lack of a better term, it's a dumb list. Structured data points take that list and add a transformation matrix that then gives a relationship from point to point, which enables software vendors traditionally to automate a lot of their solutions and automate a lot of their functions in downstream processes. Now, in this particular case, software solutions out there, they can provide either structured or unstructured data. So how do you bring those together? In Atkins' case, because they're implementing InfoPoints, they're able to bring all ranges of data together. And using InfoPoints, we can then register the data together, either by adding structure to the point cloud and using automated functions, or we can use manual functions in order to connect them together using registration points, using survey control on an as-required basis. Once we've got that data registered, we've got it prepared. Now we need to move into cleaning up the data, making it more efficient, making it lighter and easier to use through an automated denoise process, going through and identifying those points that are either invaluable or unnecessary for our data set so that we can focus on the pieces of the area, pieces of the data set, pieces of our environment that are going to be instrumental to moving forward and producing the highest fidelity models, the highest fidelity analyses that we possibly can. Now, in addition to that, automated workflows aren't going to capture everything. That's why we also have interactive tools available. We're always going to need interactive tools available. In Atkins' case, they're going through this environment. They want to be able to do collision detection through the environment and have an accurate representation of what they're going to collide with. In this particular example, as we're going to see here, we're going to go from 1 to 2. We're going to clean up some of the trash cans in this environment. We're cleaning up pieces of equipment that can be easily moved out of the way and accounted for when we're going to bring in new pieces of equipment or extract old pieces of equipment for updating and overhauling this facility. Now, when it comes to denoising, we all move that data onto separate layers, and being able to layer that data off, being able to segment that data allows you to focus on pieces at a time as it's relevant for the workflow. You're not necessarily going to worry about the outdoor environment when you want to replace the turbine inside of the facility. So we can layer that off, turn off that data set, makes it easier to use, makes it lighter, makes it easier to interrogate, and therefore, again, making that process more efficient and easier to collaborate. For the data extraction, we now want to start generating those models using either info points to do automatic extraction of primitives or other solutions that are out there on the market. Again, we're looking at a workflow. We're looking at how do we get the best results possible for our consumers, for the workflows that are required. In this particular case, using Atkins workflow, using info points, we're extracting planar elements, we're extracting piping, we're getting steel structures, all through an automated process that can then be used downstream, either to facilitate modeling capabilities or analyses. So in this particular example, something that maybe isn't going to be accounted for right out of the gate, may not be one of the big ticket items that people worry about. In Atkins' case, they needed to be able to represent guardrails so that when they bring equipment into this facility, because they only have a couple of different entrances, those guardrails are important to account for because they're going to be bolted down into the environment. They're more difficult to move unless it is absolutely necessary. So having that accurate representation, the fast extraction gives them that ability to leverage the data in an efficient manner and get to that collision detection that gives them the ability to plan out, to schedule that overhaul effectively. Drawing tools. So we were talking about it a little bit earlier. What do we do if we have an environment that's out of date? In this particular case, the designers went into their data sets and found that they had missed a piece of equipment that exists in the facility and was unaccounted for. Using info points to extract that data and take measurements that are accurate, we're now able to account for that piece of equipment and then update our model so that it now has the piece of equipment there. It's a more accurate representation, a more accurate digital twin of that environment for later on in case they need to do any future work. Now, in this particular case, we've already designed the data set, we've implemented the data set, we've built the facility. So do we just let that go, or do we go in and make sure that the facility that was built actually matches the design that was intended by the designer? In this particular case, what Atkins has done is taken a CATIA v5 native file, imported that into the point cloud environment, overlaid it, and done the validation of the as-built environment to ensure that what was built in the environment matches up with the design intent that the designers built in CATIA v5. Now we've gotten through a lot of different functions. Now we need to worry about deliverables. What happens when we've gone through our analyses, we've built our models, what do we do with them? So with Atkins' case, one of the workflows is to take the models that have been extracted from the point cloud. So we've now taken the real scan data, we've designed our models, we've extracted that data set, and now we're moving on to being able to implement them in real solutions. In this case, Atkins has taken the point cloud data, reverse engineered an existing pipe route that wasn't originally accounted for, has passed that on via CATIA v5 to their designers so they can now account for piping routes that were not initially captured or initially designed and use them to update their models, use them to overhaul the facility, and again, get that efficient workflow. Now, what happens if you don't have up-to-date data? In this particular case, Atkins has 50-year-old drawings for some of these facilities. They have to go out, take these drawings, scan them in, try to read them, and they can be difficult to interpret. Instead, to make the workflow more efficient, what they can do, take the drawings for their initial representation, combine that with the scan data with the point clouds that they can get, and then develop the design model so that it's an accurate representation of a spillway at one of their facilities. So in this case, we're transforming it from the point cloud, using the drawings as representative data, as reference data, to now get a solid model that can then be used for flow analyses, for structural analyses, and also just generic documentation for downstream processes. We're not always going to have a hyper-representative solid model to start with. Maybe we need something that is representative, that is accurate, but it may need to start in the form of a mesh. So especially with complex environments, such as going out, looking at terrain, looking at existing spillways and accounting for any of the kind of overbreak that may not have been initially accounted for. In Atkins' case, what they've done is they've segmented this environment for the terrain as well as one of the spillway walls on the eastern side of this particular dam. They generated that to a very fine mesh so that it's an accurate representation of that data. And then using that, they're now able to go into a design solution to generate a solid model that is then used for flow analysis from that particular structure. So by combining all that data together, they're able to ensure that the water flow analysis isn't just going to pass through the environment. This needs to be a watertight model so that if the water is being analyzed, it's not just going to pass through and wind up being an infinite loop. That's not what we want. We need an accurate representation of that flow, where the water is going, where those stress points are going to be. In addition to that is, again, just updating the model for documentation purposes. Using hyper-realistic mesh files, we're able to go in and combine those with design data to ensure that the models that we have are representative of the real world in current time. And this is something that can be updated readily and efficiently so that if any significant changes occur, Atkins can then very quickly identify those variances, identify those changes, and make corrections as needed. In another example here, we're talking about a much larger structure. This is just going to be kind of but in this case, what they're doing is they're trying to block off the water from going to a certain location. So they've built this structure around the environment in order to channel the water to a specific area. So that's really the end of the presentation. Again, the emphasis being that we're combining technologies, we're combining workflows in order to establish the most effective capabilities for the intended use cases. I appreciate your time. Thank you for sticking around all the way to day 3. And I hope you guys enjoy the rest of the conference that is the networking event.